Hi ladies and gentlemen, today we're going to be looking at line graphs and double line graphs and answering some questions based on some of those graphs. So let's take a look at our first example. A climatologist incorporated Alaska's monthly temperatures into her weather model. So our graph here shows the average high temperature in Juneau, Alaska for each of the months from March all the way through November. And our question is, what is the average high temperature in September? So we're going to look on the x-axis to see where September is. We're going to go up on our graph to see where the dot is, and where that dot is the average temperature of 60. All right, next question. A meteorologist kept track of the average temperature in Minneapolis for a full year. So this is from April through November. Again, you'll notice this break line here, just a heads up. If you're looking for it or not, we're missing 10 and 20 on there. Sometimes that causes a graph to be misconstrued. Okay, so the question, in which month is the average temperature 30 degrees? So I'm going to look for 30 degrees on the y-axis, and where there's a dot is all the way over at November. Next question. At Dover Consulting, the head of human resources examined how the number of employees with health care benefits varied in response to policy changes. So we have the years here on the side, and that's on the x-axis. On the y-axis, this is the number of employees who had health care benefits. So if I'm reading this, that means in 2014, there were only 100 employees who had health benefits, as opposed to in 2019, there were 600 employees with health benefits. Okay, so let's take a look at the question. Did more employees have health care benefits in 2012 or 2011? So we're going to look at these first two points of data. We have 800 for 2011 and 400 for 2012. So more employees had health care coverage in 2011 because that's a higher point. All right, to price her pieces effectively, a jewelry designer monitors the price per pound of platinum. So these are the months that she's monitoring the price per pound, and over here this is the price per pound. So if you bought 1 pound of platinum in August and another pound in September, how much would you spend in all? So let's take a look at August and September. It seems like they both have the same price of $25,000 each. So we're going to add those two values together, $25,000 and $25,000, give us $50,000. So we would spend $50,000. Next question. A real estate agent noted the rising housing prices across the United States. So down here is the year that they were checking the average household price, and on the y-axis, that is the average price for the year. So what was the average price of a house in 1991? So we're going to look where 1991 is. We're going to move up in our graph to where the dot is, and that is $100,000. So the average price of a house was $100,000. Next question. A political analyst studied voter turnouts for various U.S. elections, hoping to understand what caused the variation. So we want to figure out if the voter turnout increased or decreased between 1986 and 1994. So starting at 1986 and going to 1984, well, it started at 65 million over here, and it is increasing. The value is going up by the shape of the line and where it ends at 75 million. Since 75 million is more than 65 million, it increased. All right, now we're going to look at some double number lines. So the information here is about students at Knoxville Middle School. They're raising money for a new auditorium. So the 7th and 8th graders are raising the money. 7th graders are represented with the pink line, and the 8th graders are represented with the blue line. So we can see how much each of the grades fundraised, or how much they raised for each of the months. For example, in June, the 7th graders in pink raised $20, and the 8th graders in blue raised $40. So together they raised $60 for the month of June. Let's look at the question on the bottom. How much money did the 7th graders raise in September? So we're going to go to September on the x-axis, and we want to go up to the pink dot. That's up here. And I'm going to move over here. It matches up with $100, so the 7th graders raised $100 in the month of September. Okay, our next question, or our next problem, the theater department recorded the attendance at the high school play. There were children and adults who attended, and we want to know, did more adults attend the play on Tuesday or Saturday? So since we're only looking at the number of adults, we're going to look at the green line. The blue line is irrelevant, the number of children, and we want to take a look at Tuesday and Saturday's numbers. So Tuesday was 20, and Saturday was 100. So more adults attended on Saturday compared to Tuesday. All right, our next double number line here. The sports team at Livingston Middle School are raising money for new sports equipment. So the football team and track team are graphed on this graph here. And we want to know during April, how much more money did the track team raise than the football team? So I'm going to go to the graph at April, and the football team raised $20, and the track team raised $100. So how much more money? We're going to subtract those two. 100 minus 20 is 80. So they raised $80 more. All right, our next graph, the theater department recorded the attendance at the high school play. On Monday, how many more adults than children attended the play? So we're going to take a look at where Monday is. And I notice for the children, that's 100. And for the adults, that's 700. So the difference, how many more implies difference? 600 more adults attended compared to the children. All right, next question. A manager at Lakewood Hardware reviewed a sales report about light bulbs. So we have incandescent light bulbs in blue and fluorescent light bulbs in green. During April, how much more money was made from selling incandescent light bulbs than fluorescent light bulbs? So I'm going to look at April here. We have 40,000 for the fluorescent, and we have 60,000 for the incandescent. So how many more? That's $20,000 more when we subtract those values. And our last question here, an environmental scientist monitors some wind farms' production over time. So we have the number of years, or the year that they were measuring on the x-axis, and the kilowatts per hour on the y-axis. So how many more kilowatt hours were produced at Nate's Wind Farm in 2009 than in 2013? Well, Nate's Wind Farm is the blue line, so we're going to focus only on the blue. And we want to take a look at where 2009 is and also where 2013 is. So I'm going to circle those. We want to find the difference between those two. So we have 700 million for 2009, and I'm just going to underline it here, and over here 300 million for 2013. So the difference between those two would be 400 million when we subtract those. All right, so try it out on IXL. If you have questions, you can message me directly or up on Google Classroom. And I hope to talk to you guys soon. Have a good day. Bye-bye.